Welcome. In this video, we are going to look at different examples of functions and use the properties of continuous functions to decide where those functions are continuous. Now, you may recall that we have seen in section 1.7 that most of the functions that we have seen previously in our algebra courses are actually functions that are continuous on their domain. For example, polynomial functions, rational functions, root functions, logarithmic functions, trigonometric functions, and inverse trigonometric functions, and exponential functions, those are all functions that are continuous on their domain. So if we are given one of those functions and we are asked to decide where it is continuous, we just have to find the domain of the function. Those two problems are equivalent. But there is more to it. We can also combine continuous functions together to get other continuous functions. Indeed, in section 1.7, we have seen a result that says that if c is a constant and f and g are functions that are continuous at a given point a, then the sum, the difference, the product of f and g, multiplying a function by a constant or taking the ratio of two constants will give function that is also continuous at a. In the case of the ratio, of course, we need to make sure that g of a is not 0. Overall, this also means that those functions, meaning the sum, the difference, the ratio, the product, multiplying a function by a constant, will also be continuous on their domain if f and g are functions that are continuous on their domain. So once again, finding where a function is continuous in that case is equivalent to finding the domain of the function. A result that will also appear later on is that if we compose functions together, so if I look at f dot g, I will also get a function that is continuous on its domain provided that f and g are. Now in this example, we are given three functions and we have to decide where each of them is continuous. Now look at the first function, p of x, pause the video and decide where it is continuous. Okay, so p of x is minus x squared plus x plus 13. It's a polynomial and we have seen that polynomials are continuous on their domain, so finding where p is continuous is equivalent to finding its domain, and all polynomials have the domain which is R. Now look at the second function. F of x is the square root of 1 minus x. Now here's a little hint. F is actually a composition of two well-known functions. Now again, pause the video and try to see if you can find where that function is continuous. Okay, so since f is the composition of two functions, and with the square root function and the function 1 minus x, those two functions are continuous on their domains. So all we have to do now to find where the composition of the square root function and the polynomial function 1 minus x is continuous is to find the domain of that function. Now the square root is only defined if what's inside the square root is positive. So finding the domain is equivalent to finding where 1 minus x is positive, and that's when x is less or equal to 1. So here the domain goes from minus infinity to 1 included. And that's where the function is continuous. Now look at the third function. It's 1 over x. Pause the video and find where that function is continuous. Now this one is a very simple rational function, and rational functions are also continuous on their domain, and here the domain is everything except 0, because that would make the denominator equal to 0. We would get a division by 0 and that's not allowed. So here it's basically all real numbers except 0 that are part of the domain of g, and that's where g is continuous. So overall, p is continuous on R, f is continuous on minus infinity to 1 included, and g is continuous on R except 0. In this second example, we are given the same three functions, but now we will combine them together and we will have to decide where the resulting functions are continuous. So let's first start with the sum of p plus f. Now, pause the video, try to find what p plus f is, and try to find where it is continuous. Okay, so if we add p plus f together, we simply get minus x squared plus x plus 13 plus the square root of 1 minus x. We have seen that if we add two functions that are continuous on their domain, which is the case with p and f here, we will obtain a function that is continuous on its domain. So finding where that function is continuous is equivalent to finding its domain. Now the square root restricts the values of x that we can use here. We are only allowed to put values that will make 1 minus x positive because of the square root. So the domain is the same as the domain of f, which is all values going from minus infinity to 1 included. And this is where also the function is continuous. Now look at the product of f and g. Try to find what that is and where that function is continuous. Pause the video and come back for an answer. Okay, so f multiplied by g is simply square root of 1 minus x times 1 over x, so that's the same thing as dividing by x. So we get square root of 1 minus x divided by x. Now, again, if we multiply functions that are continuous on their domains, we will obtain a function that is continuous on its domain. So the square root only allows values going from minus infinity to 1 included, but the division by x removes a 0 from the domain. So what we will get for the domain and also for the values where the function is continuous is all values going from minus infinity to 1 included except 0, which could be written as the interval going from minus infinity to 0 excluded union with the interval going from 0 excluded to 1 included. Now let's take a look at the composition of f and p. Again, try to evaluate what that function is and where it is continuous. Pause the video and come back for the answer. Okay, so f composed with p is the same as f of p of x, so we will plug in p of x as the input to the function f. So we will get square root of 1 minus x squared plus x plus 13, which simplifies to the square root of x squared minus x minus 12. Now, because we are combining functions that are continuous on their domain, so the composition of f and p will be continuous on its domain. So all we have to do is find the domain of that function. Now, because it's the square root of something, that whatever is inside the square root has to remain positive. So we have to decide where x squared minus x minus 12 is positive. So let's write it down. So we need x squared minus x minus 12 greater or equal to 0. Now, if you think about this expression, its graph is a parabola that's actually concave up because the coefficient in front of x squared is positive, so it looks like this. So let's say this is the x-axis. To find where this expression is positive is equivalent to finding where the graph lies above the x-axis. So we need to find the two roots of the expression, if it has any. So we could use the quadratic formula, or we could just try to factor this polynomial. That's easier if we can do that. So we're trying to look for two numbers such that the product is minus 12 and the sum is minus 1. Think about it for a second. So those two numbers are minus 4 and 3. So this means that this factors as x minus 4 times x plus 3. So in other words, this is minus 3 here and this is 4. Those are the two roots. So clearly the expression is positive from here to here and from 4 to infinity. So this is where the function is continuous because that's the domain of the function. So the composition is continuous for x in the interval minus infinity minus 3 included union for infinity. Thank you for listening.